The military world is evolving at a rapid pace. The massive steel tanks that once dominated battlefields are becoming relics of the past. In their place, sleek electric machines with the ability to think, adapt, and strike with unmatched speed and precision are taking over. The questions now are, with artificial intelligence and electric powers out to play, what happens to traditional tanks? With what these new tanks are offering, what possibilities are there in how battles are fought in the future? Join us as we find out all the changes Elon Musk's secret weapon is bringing to hypersonic warfare. Military technology moves fast, and today's tanks are struggling to keep up with the rapid changes on the battlefield. The M1 Abrams tank, a symbol of American military might, is a perfect example of how yesterday's cutting-edge technology can quickly become tomorrow's burden. Designed during the Cold War in the 1980s, the M1 Abrams represents a generation of tanks built for a different kind of warfare. These massive machines weigh around 70 tons. That's as heavy as about 10 full-size SUVs combined. This incredible weight creates serious problems for military planners and soldiers on the ground. First, these heavy tanks destroy roads and infrastructure wherever they travel. A single Abrams can cause more damage to a country's highways than dozens of regular vehicles. In conflict zones with limited infrastructure, this becomes a critical logistical challenge. Military engineers must constantly repair roads or build specially reinforced pathways just to move these massive machines. Mobility is another major weakness. The tank's enormous weight makes it slow and clumsy, especially in challenging terrains like muddy fields, soft ground, or mountainous regions. During rapid deployment scenarios, these tanks become more of a liability than an asset. They struggle to navigate narrow bridges, forest paths, or urban environments where quick movement is crucial. Transportation presents another significant hurdle. Moving these tanks across continents requires specialized cargo ships, heavy-lift aircraft, and complex logistical planning. Each tank requires its own custom transport, which dramatically increases military operational costs. A single Abrams can cost millions of dollars to ship to a conflict zone. The tank's design also creates a technological trap. Every time engineers try to improve the tank by adding better armor, more powerful weapons, or advanced sensors, they increase its weight. This creates a vicious cycle. Improvements make the tank heavier, which further reduces its mobility and transportability. Modern warfare demands flexibility and rapid response. The conflicts in Ukraine have demonstrated that lighter, more adaptable vehicles often prove more effective than massive, slow-moving tanks. Smaller tanks can move quickly, consume less fuel, and adapt to changing battlefield conditions more efficiently. Countries like South Korea and Japan have already recognized these limitations. Their newest tank designs, like the K2 Black Panther, weigh significantly less, around 55 tons, and prioritize speed and maneuverability over sheer size and armor. The M1 Abrams and similar Cold War-era tanks are becoming technological dinosaurs. They represent a bygone era of warfare where massive, heavily armored vehicles were considered the ultimate weapon. Today's military requires smarter, more agile solutions that can respond quickly to complex, fast-changing global challenges. If modern tanks are struggling to survive on today's battlefields, how did we get from building thousands of tanks during World War II to our current limited production? What incredible story lies between those massive tank factories of the 1940s and today's high-tech military workshops? World War II changed tank manufacturing forever, turning it from a small-scale industry into a global production force. In those intense years, countries poured everything into building tanks, using factories that once made cars, trains, and even household goods. Entire industries shifted focus, with assembly lines running non-stop to meet the growing demand. The results were staggering. Over 2,000 tanks rolled off production lines in just a few years. This incredible effort not only boosted wartime strategies, but also showed the power of industrial collaboration on a massive scale. The United States played a particularly crucial role in this tank revolution. American factories, which had previously manufactured cars and consumer goods, quickly retooled to become tank production centers. Companies like Ford, Chrysler, and General Motors stopped making passenger vehicles and started producing military hardware at an incredible pace. In 1942, at the height of tank production, American factories were generating one tank every 60 minutes. This meant that in a single day, the United States could produce up to 24 tanks, a manufacturing miracle that shocked the world. The secret was a process called assembly line production, where each worker performed a specific task, allowing for rapid and efficient manufacturing. Different tanks served different purposes. The Sherman tank, for example, wasn't the most technologically advanced, but it was reliable, easy to repair, and could be produced quickly. American factories built 49,234 Sherman tanks during the war, more than any other tank model in history. The Soviet Union matched this production intensity. Their T-34 tank became legendary for its simplicity and effectiveness. Soviet factories could produce a T-34 in just 40 minutes at the peak of their production. Often, these tanks would roll directly from the factory floor onto trains headed to the front lines. What made this mass production possible? Several key factors came together: standardized part designs, highly specialized workers, round-the-clock factory operations, government support and funding, and simplified manufacturing processes. After World War II, tank production dramatically changed. The Cold War introduced more complex technologies, making tanks significantly more expensive and time-consuming to build. Where a World War II tank might have cost around $50,000, modern tanks can cost over $6 million each. Today's tanks require advanced electronics, sophisticated computer systems, specialized armor materials, and precision-engineered components. A single modern tank might have more computing power than entire World War II tank battalions combined. The transition from quantity to quality represents a fundamental shift in military technology. During World War II, armies believed in overwhelming the enemy through sheer numbers. Modern militaries focus on technological superiority, creating fewer but more advanced tanks that can outperform larger numbers of older models. This evolution reflects broader changes in warfare, from massive ground battles to more complex, technology-driven conflicts, where a single advanced tank can potentially neutralize multiple older vehicles. If World War II showed us how to mass-produce tanks, then how are modern conflicts revealing the true weaknesses of these massive war machines? The Russo-Ukrainian War has turned into an unexpected and harsh lesson for military strategists around the world. It has laid bare the harsh truths of modern tank warfare, showing how even the most advanced armored vehicles can be vulnerable on the battlefield. Since the war began, more than 8,000 Russian tanks have been destroyed or captured. This staggering loss has highlighted weaknesses in tank design, tactics, and deployment, flaws that no military manual or training exercise could have fully prepared for. The conflict is reshaping how nations think about tanks and their role in future wars. This conflict represents the first large-scale tank battle in decades, providing unprecedented insights into how modern armored vehicles perform under extreme conditions. Tanks that once seemed invincible are now proving surprisingly fragile against new technologies and battlefield tactics. Drone warfare has emerged as a game-changing threat. Small, inexpensive, unmanned aerial vehicles can now effectively target tanks from above, turning these multi-million-dollar machines into easy targets. Ukrainian forces have demonstrated how relatively cheap drones can disable or destroy expensive tanks with surprising efficiency. Logistics has become a critical battlefield factor. Tanks require massive amounts of fuel, ammunition, and constant maintenance. In Ukraine's challenging terrain, with muddy fields, destroyed bridges, and constantly shifting front lines, keeping tanks operational has become an enormous challenge. A tank without fuel or spare parts is essentially a massive, immobile metal target. The Russian T-72 tank has shown remarkable resilience. Despite taking significant losses, these tanks have proven surprisingly adaptable. Some models equipped with mine-clearing plows have continued functioning even after multiple direct hits, showcasing impressive engineering and crew training. However, the human element remains crucial. Tank crews require extensive training, and the psychological stress of modern combat can dramatically impact performance. The Ukrainian conflict has shown that well-trained, motivated crews can sometimes overcome technical limitations. Supply lines have become a critical vulnerability. Military planners now understand that a tank is only as effective as its ability to receive fuel, ammunition, and maintenance. Russian forces have learned this lesson expensively, with many tanks abandoned or destroyed due to broken supply chains. Western-supplied tanks like the Leopard 2 and Abrams have struggled to adapt to Ukraine's complex battlefield environment. Their sophisticated systems, designed for NATO's anticipated European battlefield, have proven less flexible than expected. The conflict has also highlighted the importance of combined arms warfare. Tanks cannot operate alone. They require close coordination with infantry, artillery, and air support. Isolated tanks become easy targets for modern anti-tank weapons. Electronic warfare has emerged as a critical factor. The ability to disrupt enemy communications, jam guidance systems, and create battlefield confusion can neutralize even the most advanced tanks. As military strategists analyze this conflict, one thing becomes clear: tank design must evolve. The next generation of tanks will need to be lighter, more adaptable, and better integrated with digital technologies. If modern tanks are struggling to survive on complex battlefields, how will engineers solve these massive challenges? What revolutionary technologies could transform tanks from vulnerable metal boxes into intelligent, adaptive warriors? Military engineers are completely rethinking tank design, creating machines that look nothing like their Cold War ancestors. The next generation of tanks will be smaller, smarter, and more adaptable than ever before. Size and weight are the first major targets for transformation. Traditional tanks weighing 70 tons will give way to lighter, more agile vehicles. Countries like South Korea and Japan are already developing tanks around 50 tons, prioritizing speed and maneuverability over pure armor thickness. Hybrid electric engines represent a massive technological leap. These advanced power systems combine traditional diesel engines with electric motors, dramatically improving fuel efficiency. The U.S. Army's Abrams X technology demonstration vehicle already consumes 50% less fuel than current models, a game-changing improvement for military logistics. Artificial intelligence will revolutionize tank operations. Future tanks won't just be machines. They'll be intelligent platforms capable of processing battlefield information in milliseconds. Advanced computer systems will help crews make faster decisions, track multiple threats simultaneously, and even predict potential enemy movements. Stealth technology will become critical. Modern tanks will feature advanced materials and designs that reduce their heat, noise, and electronic signatures. Special thermal nets and adaptive camouflage will make these vehicles incredibly difficult to detect, turning them into digital chameleons on the battlefield. Unmanned systems will transform tank warfare. Future tanks will operate like command centers, coordinating multiple drone and robotic assets. A single tank could potentially control several unmanned ground vehicles and aerial drones, extending its operational reach far beyond traditional limitations. Armor protection is getting smarter. Instead of just being thick and heavy, future tank armor will actively defend against threats. Systems like Israel's Trophy Active Protection technology can detect and neutralize incoming rockets and missiles before they even reach the tank. Automated loading systems will reduce crew requirements. Where traditional tanks needed multiple crew members to load ammunition, new designs will use sophisticated robotic systems. This reduces human error and allows smaller, more efficient tank crews. Larger, more powerful cannons are also on the horizon. Future tanks might feature 140mm guns compared to today's standard 120mm weapons. These larger cannons will provide increased range and destructive capabilities. The most radical change might be the tank's fundamental design philosophy. Engineers are treating tanks more like software platforms that can be rapidly upgraded. Similar to how smartphones receive software updates, future tanks could have their capabilities enhanced through digital modifications. This technological revolution isn't just about building better weapons. It's about creating more efficient, adaptable, and ultimately more responsible military technologies that can potentially reduce human casualties and operational costs. If tanks are becoming more like advanced computers on wheels, how are military engineers completely redesigning their approach to building these war machines? Military technology is changing faster than ever, and tanks are right at the heart of this transformation. Engineers are reimagining tanks, not as simple machines of war, but as advanced digital platforms designed to evolve over time. The idea is to make tanks smarter and more flexible, adapting to new challenges just like the latest tech gadgets. Surprisingly, the inspiration for this shift comes from technology companies like Tesla. Just as smartphones gets regular updates to boost performance and add features, engineers aim to build tanks that can be upgraded with new software and systems. This means a tank's capabilities could improve without the need to tear it apart or start from scratch. This approach would make tanks more efficient, cost-effective, and better prepared for the unpredictable demands of future battlefields. Instead of becoming outdated, these tanks could stay ahead, much like the technology we use every day. This approach means tanks will become more like sophisticated computers with wheels. Instead of designing an entirely new tank every decade, military teams can now modify existing platforms through software updates, sensor replacements, and digital enhancements. A tank built today could potentially remain cutting edge for much longer than previous generations. Modern militaries are borrowing strategies from the tech world. They're creating modular designs that allow rapid component swapping. An electrical system can be upgraded, a new AI targeting computer installed, or advanced communication networks integrated, all without rebuilding the entire tank. Artificial intelligence is driving this transformation. Future tanks will have onboard systems capable of learning and adapting. These digital brains will help crews make faster decisions, predict enemy movements, and even suggest tactical strategies based on real-time battlefield information. Sensor technology plays a crucial role in this new design philosophy. Advanced sensors will continuously collect data about the tank's performance, environmental conditions, and potential threats. These sensors can instantly communicate with other vehicles, creating a networked battlefield ecosystem. Software will become as important as mechanical components. Military programmers will develop specialized algorithms that help tanks operate more efficiently. These digital systems can optimize fuel consumption, predict maintenance needs, and even help coordinate with unmanned aerial and ground vehicles. The concept of upgradability extends beyond software. Military engineers are designing tanks with standardized connection points and modular components. This means a new weapon system, advanced armor panel, or communication module can be quickly integrated without extensive redesign. Cybersecurity becomes a critical consideration. These digital tanks must be protected against potential electronic attacks. Military programmers are developing sophisticated encryption and defensive systems to prevent enemy interference with these advanced platforms. The economic benefits are significant. Traditional tank development costs billions of dollars and takes years. This new approach allows faster, more cost-effective improvements. A software update could potentially enhance a tank's capabilities overnight. Global technology trends are driving this transformation. The same principles that make smartphones and electric cars continuously improve are now being applied to military technology. Tanks are no longer just mechanical weapons. They're becoming intelligent, adaptable digital systems. This revolution represents more than technological advancement. It's a fundamental rethinking of how military technologies can be developed, maintained, and improved in an increasingly complex and fast-changing world. If tanks are becoming digital platforms that can be updated like smartphones, what incredible technologies are military engineers developing to make these machines even more powerful and advanced? Military technology is pushing the boundaries of what's possible, and tank development is at the forefront of this technological revolution. Engineers are exploring innovations that sound like they've been pulled straight from science fiction. Cannon technology is taking a massive leap forward. Traditional tanks have used 120mm guns for decades, but the next generation might feature enormous 140mm cannons. These massive weapons will provide unprecedented range and destructive power, allowing tanks to engage targets from distances previously unimaginable. Automated loading systems are changing how tanks operate internally. Instead of human crew members manually loading ammunition, a time-consuming and dangerous process, robotic systems can now load shells with incredible speed and precision. This means faster firing rates and reduced risk to human operators. Electronic warfare capabilities are becoming increasingly sophisticated. Future tanks will carry advanced jamming equipment designed to disrupt enemy communication systems, disable drone guidance, and create electronic fog on the battlefield. These systems can essentially blind and confuse enemy technologies before a single shot is fired. Artificial intelligence will revolutionize target acquisition and tracking. Advanced computer systems can now identify, track, and prioritize multiple threats simultaneously. A tank's AI could potentially detect an enemy vehicle, calculate its movement, and recommend the most effective response in milliseconds. Protection systems are getting smarter and more proactive. Instead of just being heavily armored, tanks will now have active defense mechanisms. Systems like Israel's trophy technology can detect incoming rockets or missiles and neutralize them before they even reach the tank. It's like having an invisible shield that can shoot down incoming threats. Stealth technology is moving beyond traditional camouflage. Future tanks will use advanced materials and design techniques to reduce their heat signatures, electromagnetic emissions, and acoustic profiles. This means tanks could potentially move across battlefields almost undetected by modern sensing technologies. Hybrid power systems are transforming tank mobility. By combining traditional diesel engines with electric motors, tanks can become significantly more fuel efficient and quieter. These hybrid systems also provide more flexible power management, allowing tanks to operate more silently and for longer periods. Unmanned capabilities are expanding rapidly. Tanks are becoming command centers that can control multiple robotic assets. A single tank could potentially coordinate several ground and aerial drones, extending its operational reach far beyond traditional limitations. Miniaturization of technology allows for more complex systems in smaller packages. Advanced sensors, communication equipment, and computational systems can now be packed into incredibly compact spaces, making tanks lighter and more agile without sacrificing capabilities. The tanks of tomorrow will be more than just weapons. They'll be intelligent, adaptive systems that redefine the very concept of armored warfare. Thanks for watching. While you are still here, click on the link on your screen to check out another of our videos. See you there.